Is our universe truly unique? Or have countless others existed before? Has the universe we know always been the only one? Or is it merely the latest chapter in an endless cosmic epic? A single verse in an infinite poem of creation, destruction, and rebirth? A growing number of astrophysicists are beginning to suspect that the answers to these questions lie not just in theory, but in tangible evidence. Evidence brought to us by the most powerful space observatory ever built, the James Webb Space Telescope. Once again, Webb has peered deeper into the cosmos than any instrument before it. And once again, it has shattered our assumptions about how the universe began, how it evolved, and, perhaps most provocatively, what may have come before. A challenge to the cosmic dawn. The James Webb Space Telescope has uncovered something extraordinary. Scanning a quiet corner of the sky near the Big Dipper, it detected faint, ancient points of light. These weren't just ordinary stars, they were galaxies. And their light had traveled for over 13 billion years to reach us, originating from a time just 500 to 700 million years after the Big Bang. But there was a problem, a very big problem. These galaxies, despite forming during the so-called cosmic dawn, appeared to be impossibly massive. Some were comparable in scale to our own Milky Way, a fully mature, sprawling galaxy that took billions of years to evolve. According to our current models, there simply shouldn't have been enough normal matter, known as baryonic matter, in the early universe to form such enormous galactic structures so quickly. These galaxies, dubbed universe breakers by baffled astronomers, defy nearly everything we thought we knew about cosmic evolution. And this wasn't an isolated case. Over time, Webb has detected more such anomalies. Galaxies too bright, too big, and too evolved for their age, combined with long-standing discrepancies in how we measure the universe's expansion rate. These observations are painting a picture of the cosmos that looks radically different from what textbooks describe. The expanding mystery, a broken Hubble constant? At the heart of cosmological measurements is a value known as the Hubble constant, the rate at which the universe is expanding. When calculated using the cosmic microwave background, CMB, the afterglow of the Big Bang, the Hubble constant is around 67 kilometers per second per megaparsec. But when measured through observations of supernovae, red giant stars, gravitational lenses, and other local indicators, the value jumps to 73 kilometers per second per megaparsec. This stubborn mismatch has puzzled scientists for years. Webb's observations have only deepened the mystery, confirming once again that the universe appears to be expanding faster than our early universe models would suggest. So what's going on? Could this discrepancy point to a more profound, underlying truth about our universe? Some scientists now believe that the key might lie outside our universe entirely, merging universes and a multiversal cosmos. A bold new theory proposes that our universe is not an isolated entity, but is instead interacting with other universes. This multiversal hypothesis suggests that our cosmos may have been born not in a singular Big Bang, but through an interdimensional merging, a young universe absorbed into a larger mother universe. Mathematicians and physicists have begun constructing models to test what might happen if multiple universes interacted. These models reveal something stunning. If universes can merge or influence each other gravitationally or through quantum fields, the resulting dynamics could look very much like what we observe, an accelerating universe with an unexpectedly high Hubble constant. In fact, the expansion rate predicted by such models aligns better with modern observations than the traditional Big Bang model. Could it be, then, that our cosmos is not alone, but one of many, each arising from, or giving birth to, another? A galaxy that shouldn't exist. The implications of Webb's discoveries grow even more astonishing when we consider a specific galaxy, Jade's GS Z11-1, an ancient star cluster that formed just 330 million years after the Big Bang. In cosmic terms, this is an eye blink after the beginning of time. And yet, this galaxy is emitting an extraordinary amount of Lyman alpha radiation, ultraviolet light typically blocked by the thick, neutral hydrogen that filled the early universe. According to standard cosmology, Such radiation shouldn't have escaped. The intergalactic medium was supposed to be opaque at that time, still in the so-called Dark Ages, before reionization had fully kicked in. But somehow, this galaxy carved out a 650,000 light-year-wide bubble of ionized gas, allowing UV light to flood outward into space. That means either reionization began much earlier than we thought, or this galaxy, and perhaps many like it, had extraordinary properties we don't yet understand. Astronomers are stunned. "We shouldn't have found a galaxy like this at all," said Kevin Heinlein, one of the study's authors. His words echo a growing sentiment across the astronomical community. Something fundamental is missing from our models. Rewriting the beginning. Roger Penrose and the Cyclical Universe. This brings us to one of the most provocative ideas in modern cosmology, the conformal cyclic cosmology proposed by British Nobel Prize-winning physicist Sir Roger Penrose. Penrose argues that the Big Bang wasn't the beginning of everything, just the latest bounce in an eternal cycle. In his view, the universe continually evolves from a state of intense order to one of maximum entropy, where everything is diluted, cold, and uniform, before transitioning back into a new phase of existence. But this is more than just philosophical speculation. Penrose and his colleagues claim to have found concrete evidence in the cosmic microwave background radiation, subtle, circular patterns that could be fossils of a previous universe. These mysterious Hawking points, named after Penrose's late colleague Stephen Hawking, may be the final echoes of supermassive black holes that once existed in a previous cosmic era. As these black holes evaporated through Hawking radiation, they might have injected a burst of energy into the next universe, leaving behind circular imprints in the CMB, visible to us today as disks about the size of the full moon. Penrose believes these are real signatures from the universe that came before ours, a previous cosmic aeon that ended in stillness and exploded into new life. Hashtag the universe. One of many? Taken together, Webb's revelations of impossible galaxies, the mismatched expansion rates, early UV-emitting stars, and Penrose's cyclic model. We are faced with a breathtaking possibility. That the Big Bang was not a beginning, but a bridge. That our universe is one of countless others, arising and fading like waves upon an eternal sea. That black holes do not just consume, but also create, seeding future universes with the radiation of their dying breaths. And that light from the oldest galaxies may not only be showing us the past, but hinting at a time before time. Conclusion: a new cosmic story begins. The James Webb Space Telescope is revolutionizing our understanding of the universe. It's not just giving us sharper images or more detailed spectra. It's challenging the very foundations of our cosmology, raising questions about time, space, and the nature of reality itself. Are we living in a universe that had no true beginning? One that will give rise to others in the future? Could the glowing embers of ancient black holes whisper the secrets of previous cosmoses? We are only at the beginning of a grand cosmic mystery, one that may ultimately reveal that we are part of a universe far older, far stranger, and far more interconnected than we ever imagined.